Okay, 7.2, the normal distribution and z-scores. All right, so the frequency polygon approximates the shape of the frequency distribution. So when we have a frequency distribution bar graph, we take the midpoints of each of those bars, okay? And basically when we take the midpoint of each of those bars, we connect those midpoints of each bar, and when we create, what we can create is something called a frequency polygon. That frequency polygon basically describes the shape of the frequency distribution. Now, you must use a range of values to determine the theoretical probability for a continuous random variable. The probability that a continuous random variable takes on any single value is 0. And we saw that yesterday, or in the previous lesson, with respect to where we have one specific value, let's say at one point somewhere on this frequency distribution, a single specific value, no more and no less than this particular value. And what we're doing here is we're saying that the probability of getting that exact value at that exact moment is impossible. So it's like saying 1 over a million or 1 over 10 million, for example. So the idea is that the probability of getting that particular value is 0. Now, a normal distribution, as we see here, is a probability distribution around a central value, dropping off symmetrically on the right and left, forming a bell-like shape. So we can see that this creates this bell curve. That's what they call a normal distribution, is a bell curve. Now, you can determine the probability that a variable will lie within a range of values by finding an area underneath the normal distribution. You can use z-scores to determine probabilities, either from a table or by using technology. And folks, we're going to use a table to determine using the z-score, we're going to determine the probability. And those tables can be found in your textbook on page 480 to 481. We're going to use z-scores to find area under a curve. For example, z-score is the distance it is, this is being the mean right here in the middle. A z-score is a specific value somewhere along here. That would be your z-score, how many standard deviations away it is. And when we calculate the probability using that z-score, what that will give us is the area under the curve of the bell that is lower. The ones we have in this textbook are the ones that are lower than that z-score. If we want it above, what we would do is do 1 minus that value that we found for this z-score to find the area that's above, so the complement. We're going to look at examples of that in just a second. Okay, sorry. Let's look at example number 1. A men's clothing store kept records of the waist sizes of a sample of their customers, measured to the nearest quarter of an inch. The table shows the relative frequencies. What is the probability that a customer has a waist size between 30 and 32 inches, of more than 36 inches, between 30 and 36 inches, and exactly 38 inches? So what we're looking at here is we're going to determine the problem. Now, thankfully for us in this table, it gives us the relative frequency of that particular size occurring. So, what is the probability that a customer has a waist size between 30 and 32? Between 30 and 32 would be this, and that, okay, sorry folks, between 30 and 32, well, between 30 and 32, we're looking at values of 0.175. So a 17.5% chance that we have a customer in that waist size. What about a customer more than 36 inches? More than 36 inches would cover this whole area here, and what we would do is add up these values. When we add up these values, we get 20.5%. And then of values between 30 and 36, 30 and 36 means we need to get those values. We add those values up, and we get 6, 77% chance that we have a customer in this range of sizes. What's our probability of exactly 38 inches? And we know from the example earlier that we can say that to get exactly 38 and not even a smidge more or a smidge less means that it will have a probability of 0, folks. There's no way the likelihood of that happening is so rare. All right, another example. Example 2. Kunal is trying for the school football team. He wants to know how he can kick a ball for a field goal. The table shows the data. So here's his tries, and we need to determine the mean and standard deviation of the data. So when we try and find the mean, we find out that the mean is going to be adding up all the numbers and dividing by the number of numbers, and we will get 35.2 yards. So we add up all the numbers, divide by 20, and we will get 35.2 yards. The standard deviation is going to be 9.567 yards. Or 9.5675 yards. Now remember, folks, I hope you remember how to calculate the standard deviation. Now, we want to calculate the probability that Kunal kicks a distance of less than 30 yards. So if he's going to kick less than 30 yards, so x is going to be less than 30 yards, means that we have to find the z-score, which is 30 minus 35.2, so 30 minus the mean, divided by the standard deviation, and that gives us negative 0.5435. Now, what we need to do next is look on the chart on page 480 to 481 and find a z-score of negative 0.54. Negative 0.54 means we will have a probability of approximate. Now, these are all approximations, folks, because again, we're really rounding these numbers so that they will have some values off, but a very close number to 0.2946, right from the table, folks. So you need to go on the table, and I'm just going to give you an idea how to do that. I don't have a table in front of me to use, but I can tell you when you read off the chart, you're going to look for the positive side, so there's a positive side, and over here you're going to look for the tens column, so you're going to look for positive, and then there's a negative. We want the negative 0.54, so we look for the negative, and we find 0. Sorry, folks. So you're going to find 0.5, and then across the top, you're going to see a 0.04, and we're going to go across the 0.5, down the 0.04, to find the value that you're looking for in the chart. Again, it's negative 0.5, and then across the top is 0.04, so the hundredths place is on the top, the tenths place is along the side, and you find the matching z-score, and it turns out to be 0.2946. Part C is what is the probability that Kunal kicks a distance of 20 to 40 yards? To kick between 20 and 40 yards, we need to look at the following. And that is, what we need to see is we need to calculate the z-score for 40. So we find the z-score for 40, and we find the z-score for 20. Once we find these two z-scores, we then can take the z-scores and subtract the probabilities that we get for these two z-scores. So the first probability of 40 will be 0.6915. Then we go and find the z-score for negative 1.59, the probability of the z-score for negative 1.59, and we get a value of, and let's just erase all these red markings here so that we can get the answer. Just a moment, folks. Okay, so we're looking at the z-scores of 0.5 and the z-score for negative 1.59. We find the probabilities using the chart on page 480 to 481. of 0.6915, subtract 0.0559, and that will equal an answer of 0.6356, which means we have 63.56% chance of having or Kanal has a 63.56% chance of kicking a ball a distance of 20 yards to 40 yards. All right, folks. That's the end of the video. Have a numerical day.